Hello friends, today we are taking one more problem on the virtual work. So this is the problem, this is the figure of the problem. The problem is the limb cage consisting of two bars and sliding a block each loaded as shown in the figure. Means these are the two bars and this is the block. This is shown in the figure and held in the equilibrium by force P. Means the force P is applied at the block. Because of this force P, this complete figure is in the equilibrium, means it is a stable because of this force is applied towards the left, applied to the sliding block. Each bar weighs 160 Newton and bar of same length. So these two bars having the weight 160 Newton, both the bars having the weight 160 Newton and the length also same. Using the principle of virtual work, determine the magnitude of force P. Means we have to determine the magnitude of this force P. Means there are two bars of same length, same weight, and this complete figure is in the equilibrium only because of this block, and on the block the load P is applied towards the left. So we have to find the magnitude of this force P by using the principle of virtual work. So in this kind of problem we have to decide the origin of the figure. We may decide A, B, C, D or E, but if we decide either A or C, this will be very easy to solve the problem. So best way that we will decide the origin A as the origin of this figure. Once we decide this A as the origin of the figure, we will draw one vertical line that is represented as a y-axis and another line as a horizontal line that is represented as a x-axis from the origin. Then the load 160 Newton of this bar will be acting at the center of the bar. So total length of the bar is twice L, and this is twice L, this is the twice L. So at the distance of L from A, 160 Newton load is applied at a vertically downward direction. In this case also this total length is a twice L. So at a distance of L from this point C, the load 160 Newton of this bar is acting towards downward. Again the load 250 Newtons are acting on the body, that is given in the problem. So consider A as the origin. So we have to find respective horizontal and vertical distances from the origin A. Vertical and horizontal distance from origin A. For example, this force is a vertical force, 160 Newton is force is a vertical force. So we will be find vertical distance from the origin of 160 Newton and between these horizontal axis. Means we will find vertical distance. Vertical distance means the distance of origin of this force from horizontal axis X. And similarly again we will be find vertical distance of origin of this particular 160 Newton force that is at C, and origin means this distance we will be find for vertical forces. For horizontal forces we will be find the distance from y-axis. So horizontal distance we will be find. In this case also the point C we will find this horizontal distance, and for point D means force is vertically upward, so we will be find the origin distance between the origin of the force and this x-axis passing through the point A. Similarly the force acting vertically downward 160, so the distance of the origin of force and this horizontal x-axis, this distance we will be find. Means if the force is vertical we have to find a vertical distance from x-axis. If the force is horizontal we have to find a horizontal distance from the y-axis. So let us see, this is A is the origin. Let us draw one vertical dotted line up to the x-axis from point D. Let this angle is a theta. So what is this angle is a theta. This angle is a theta. So use a trigonometric formula. So we can write sine theta is equal to, what is sine theta? This is the opposite side. So opposite side we will represented, this height will be YD. It is acting from the height from the point D. So that is why we will represent that this distance is a YD, this distance is a YE, this distance is a YB, and this distance is a XB, and this distance is a XC. So YD, so this distance is a YD. So opposite, this is the opposite side, YD opposite by hypotenuse length is a L. Therefore YD is equal to L sine theta. Similarly, we can find this distance also. Again, let this angle is a theta. This angle is a theta. So sine theta is equal to, this distance is a YD. So opposite side is a YB divided by this L. This distance is twice L. This distance is a twice L. So twice L. So YB is equal to twice L sine theta. Then next force is a 200 Newton. 200 Newton. So 200 Newton is a 50 Newton. So this force is a horizontal force. This force is a horizontal force. So we need to find horizontal distance from y-axis. So let this distance is represented by XB. So this distance is a XB. How to find this distance? So again same. We use the trigonometric formula. Cos theta is equal to adjacent side, means this distance and this distance will be same. This distance and this distance will be same. That is why we will be use same angle. Cos theta is equal to adjacent side by hypotenuse. Adjacent side, this is XB, means this is XB. So XB divided by twice L. So XB is equal to 2L cos theta. So this distance is XB distance is obtained. Then this distance, what is this distance? Again use trigonometric formula. This angle is a theta. This angle is a theta. All the dimensions are same, means this theta and this theta will be same. So again sine theta is equal to, this angle is theta. Sine theta is equal to opposite side, means this side will be represented by YE divided by this hypotenuse L. So YE is equal to L sine theta. Then we have to find this distance XC. How to find this distance XC? This distance is XB. So and we know we obtained this distance twice L cos theta. So this distance will be also twice L cos theta. This distance is twice L cos theta. This distance is also twice L cos theta. So total distance XC is equal to 4L cos theta. 4L cos theta. Now these are the distances, vertical and horizontal distances. If you differentiate this, with respect to the theta, we will be get displacement. We will get the respective displacement. For example, if you differentiate this particular YD with respect to delta theta, so so it will become a displacement. So delta differentiate all these terms with respect to theta. So what is the equation? What is the delta YD is equal to, what is the displacement of this distance? This will become L sine का differentiation cos theta into delta theta. So it will become L cos delta theta. Similarly YB, here sine differentiate it, so it will become delta YB is equal to twice L sine differentiation, it become cos theta into delta theta. Now this is delta XB is equal to twice L sine differentiation is minus, so it become minus sine theta into delta theta. Then this distance delta YE is equal to delta ye is equal to, it will become L sine become cos theta into delta theta. Again delta xc is equal to 4L sine become cos becomes sine minus sine theta into delta theta. So we get all the displacements. Now we will be use the principle of virtual work. To use a principle of virtual work, principle of virtual work. So we all know work done is equal to force into displacement. We all know force into displacement. So we will be multiplied force with respect to the respective displacement, and we will be add all the work done, and at the end we will be equated to the 0. We will be equated to the 0. Now let us see first force. This is the first force 160. 160 is a vertically downward, so we will be write minus 160 multiplied by displacement at yd. So it is L cos theta into delta theta. Next force, this 200. 200 is a vertically upward, so we will be write plus 200. It's a displacement is a delta yb. Delta yb is getting 2 L cos theta into delta theta plus. This is a 50. 50 is acting towards the right. 50 is acting towards the right. So that is why we will take 50 as a positive. 50, and respect to displacement is a minus twice L sine theta into delta theta. Then next force is this 160. This 160 again vertically downward, so minus 160. Then delta ye kitna hai? What is the delta ye? Delta ye is getting L cos theta into delta theta. Then this P is acting towards the left in this direction. It is left, so that is why we will take and horizontally. So minus P into displacement in x direction is minus 4L sine theta into delta theta. So delta theta term is a common, and this complete equation will be equal to 0 because virtual displacement is there. So final work done will be equal to 0. So now this delta theta is the common. So remove the delta theta, and the theta value will be a 45 degree. Why 45 degree? Because all the members having the same length, and is it given? No. So but all the members this angle of inclination is 45 degree, because it is a similar triangle. It is a similar triangle. So all the sides are same. All the sides are same. That is why this angle is 45. This angle is 45 degree. Then if you put the value of theta, we will be obtaining the value of P is equal to. We will be obtaining the value of P is equal to 5 Newton, almost equal to 5 Newton. That's all.